This is a podcast of Scripps Institution of Oceanography at UC San Diego. To learn more about how you can support Scripps, visit us online at scripps.ucsd.edu. This fall, a network of measurement devices spread out through the world's oceans will reach a key milestone. The Argo program is expected to reach its target of having 3,000 floats simultaneously collecting data on what are considered the vital signs of the oceans: water temperature, salinity, and velocity. But nearly a decade after the array's first floats were launched off the coast of Australia, the Scripps oceanography scientists, who were the main forces behind the program, say that the celebration will come later. Physical oceanographers Dean Remick and Russ Davis say that if the international effort is to meet its most important scientific goals, support for it must continue for years to come.
We have weather balloons that fly up through the atmosphere measuring temperature and humidity, and by having these in many places, in many nations, we get data from around the globe, where people are at least, and from that data we can put together a picture of what the atmosphere is doing at any given time. Well, the idea of the Argo program is exactly the same thing except upside down. Instead of temperature and humidity, we measure temperature and salinity. Those are the things that determine density of seawater, and we try to get a whole picture of what's going on everywhere.
One way of explaining it, I think, would be to look at what we can do globally with the Argo data set by measuring temperature, salinity, and velocity. And for example, suppose we're interested in variability of sea surface height. Very high priority for understanding the climate system is to understand how quickly the ocean surface height is increasing and how that's distributed spatially. Well, there are two components to sea surface height. One is the density of the water column, temperature mostly, but also salinity. And the other is the distribution of mass in the ocean. More water in one place, less in another, because of ocean circulation. And so an Argo float, in a sense, measures all of these things. It measures the changing height of the water column due to changes in density, and it measures the redistribution of mass by ocean circulation.
Even though Argo needs decades to reach its full potential, the network already provides immediate help to both climate researchers and to ocean forecast centers that are predicting the next El Niño event or the strength of the next tropical cyclone season. The Argo scientists are especially interested in what the floats can tell them about long-term cycles. Over time, the network will be able to track phenomena strongly influenced by climate change, such as changes in ocean salinity, which gives scientists clues about the rate at which the world's landlocked glaciers are melting. Even more important is what it can tell scientists about overall sea level rise.
Everybody's sort of going, gosh, if I only had 10 more years, couldn't we make it go back? Find out how it was 10 years ago. And you know, at some point we will have enough information to really be able to see these very slow changes directly with this system.
Sea level rise is caused by two phenomena. One is warming the oceans. When you warm a teapot full of water, eventually it overflows because the water expands, and the oceans are no different from that. The oceans have expanded by warming at a rate of something like 0.5 millimeter per year over the last 50 years. The other reason that sea level rises is because more water goes into the oceans when glaciers melt. And of course there are active programs at measuring the volume of ice sheets in Antarctica and Greenland and other places. But in the ocean, when land ice melts and runs into the ocean, the salinity of the water decreases. So that's something else that Argo sees, and we can view very small decreases in the mean salinity of the oceans because of the addition of water.
We just sort of have the first data point in a lot of these processes, but it's working very well. We're addressing questions of global significance like sea level rise and the heat storage in the ocean. We hear people occasionally still saying, oh no, the globe isn't really warming. It's just because you're only measuring things at airports and where people are. Well, there are not very many people out there in the ocean, and the evidence that the ocean is getting warmer is unambiguous and is not subject to all this argument about heat islands and stuff like that. It's just getting warmer. So there's some things we can deliver on right now, and I think there are a lot more things that we will learn from this thing as we watch it over time. It's like having your first weather maps. I mean, what would you know about the atmosphere if you'd never seen a weather map?
Climate is I think, recognized now as a very important problem, and we need to keep observing the state of the climate system. That means that the need for a program like Argo continues indefinitely. The technology may evolve. I can't say that we'll be putting the same kind of instruments out over a long period of time, but we need to keep making these measurements for the indefinite future.
This is Wendy Hunter Barker for Scripps Institution of Oceanography at UC San Diego.